Okay, so this is page 3 of the Unit 5 Part 4 packet. We're going to be going over functions as rules and tables, and we're going to go over some vocabulary. So the vocabulary you need to know is domain, range, and function. And domain is the set of all the X values or the input values in an input-output table. And the range is a set of all the output or Y values in a function or an input-output table. And a function is a set of all the inputs and the outputs paired together. And for every input, there is only one output. That's what makes it a function. So we will go over that again. But if you look at this first input-output table, you see that the domain is 1, 2, 3, and 4. And then the range would be 5, 10, 15, and 20. And for this particular one, and we will go over finding the rules, but the rule here is y equals 5x. Because every time you put the input of 1 here, 5 times 1 is 5, you get an output of 5. If you put an input of 2, 2 times 5 is 10, you get an output of 10, etc. Now, the reason this is a function is because every time you put a specific input in, you only get one output per that input, and that's what a function is. Here, I can recognize that it's a function because none of the X values repeat. And if none of the X values repeat, you're not going to get a different Y for a different X if there are no different X's. Okay, so now we're going to look at another table, and I want you to identify the domain and then identify the range. So here, our domain would be our input, which is 0, 2, 4, 6. And our range would be the output, which is 24, 27, 30, 33. Okay, now for this next table, the input is easy because it's 0, 1, 2, 4. But now that's the domain. The range, we don't repeat numbers. So you might be tempted to write 5, 2, 2, 1, but we just write 5, 2, 1. And some people like you to put it in order. It depends on what your teacher asks for. You do not have to put it in order for me. Okay, so domain is all X values, range is all Y values. Domain is your input, range is your output. So let's look at the next one. Our input, or X, is 4, 7, 11, 13. Our output, or Y, is 10, 35, 45. Notice I did not repeat numbers. Okay, now we're going to go over again how to recognize if it's a function or not. So instead of an input-output table, we're using what's called mapping. This is a mapping diagram. This is your input, this is your output. And it shows that this particular input matches to this particular output. This 2 matches to the 5. So this input, you only get one output, and it's 5. And for 3, you only get one output, but it's also 5. And that's okay. It's okay if the outputs repeat. You just don't want the inputs. So every time I put a 2 in, I get a 5. I don't put a 2 in and get a different number other than 5. That's what makes it a function. Now, if you look at this next mapping diagram, when I put a 5 in, sometimes I get a 2, sometimes I get a 3. That is not a function, okay? If I notice there's 2 arrows coming out of one X value. Whenever that happens, it's not a function. Now, if you were to take these mapping diagrams and write them as a set of ordered pairs, the one on the left would be 1, 4, 2, 5, 3, 5. Notice none of the X's repeat, and it is a function. For this one, we have 4, 1, 5, 2, 5, 3. Notice the 5 repeats, not a function. Notice 2 arrows coming out of the 5, not a function. Those are quick ways of recognizing if it's not a function. Now, on this next page, I want you to try to do A, B, C, D, and E and see if you can identify whether these are functions or not. So you can stop the video, and when you're ready, start it again and see if you are correct. So this first one is indeed a function because none of the x values repeat. So every time I put in a 4, I only get a 1. I put in an 8, I only get a 2. I put in a 2, I only get a 3. This next one is not a function because sometimes when I put in a 3, I get a 5, and sometimes when I put in a 3, I get a 2. So that is not a function. And C is not a function because sometimes 2 gives you a 2, but sometimes 2 gives you a 4. Notice my 2's repeat. That's not a function. Same thing with D. This is not a function because sometimes I put in a 5 and get a 3. Sometimes I put in 5, get a 4. Your x's repeat. It's not a function. Here, none of your x's repeat, so it is a function. Okay. Now, this says make a table for a function. So if we're given a rule, like here, y equals 3x, I put the x here, I put the rule or the value for y here. It gives me my domain. My domain are my x values. So here I put 0, 1, 2, 3. And then to get the y values, I apply the rule. So y equals 3 times x. If x is 0, this is 0. If x is 1, this is 3. If x is 2, this is 6. If x is 3, this is 9. So my new range is 0, 3, 6, 9. Now, my next one says my function rule is y equals x minus 3. So I put that here, y equals x minus 3, and I put x here. Then it gives me my domain. I put my domain values here. And now I apply the rule to find the range. So 12 minus 3 is 9, 15 minus 3 is 12, 22 minus 3 is 19, and 30 minus 3 is 27. So my range is 9, 12, 19, 27. Okay. Now we turn the page. And on this page, we're going to try to come up with the rule. So before, we were given the rule and the domain, and you came up with the range. Now you're given the domain and the range, and you come up with the rule. And I'm going to show you how to come up with the rule. And I also want to emphasize, your rule is always an equation. It's always going to be y equals something x, okay? So you have to make sure your rule is always a complete equation. The way you come up with the rule is you look and see if there's a pattern in your outputs. Well, how is this changing? And here I notice every time it's going up by 4. And then I look at my x's, and every time they are going up by 2. So when you have a situation where there's a constant change in y and a constant change in x, we call this delta y over delta x. And that means the change in y, which is 4, over the change in x is 2. That equals 2. 2 is our multiplier. That means every time I'm multiplying by 2, I may be done, I may have to do something else, but I always start with the multiplier. So I write a rule of y equals 2x. And I look and I say, wow, look, that works. Because every time I double my x value, I get my y value. So I am done in this case. And I found out that the rule is y equals 2x. Now I'm going to look at this next one. And I'm looking and I'm like, well, I'm not multiplying by the same thing every time. So let me do what I did before. This is plus 1. This is plus 1. This is plus 1 plus 1. This is plus 1, plus 1, plus 1. So I know my multiplier is 1. So y equals 1x. But when I put in my input of 1 times 1, I get y equals 1, but y doesn't equal 1. So what do I have to do to a 1 to turn it into a 0? I have to subtract 1. So I think my rule is y equals x minus 1, but I'm going to test it. So 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. 5 minus 1. So that is my rule, and it worked. So, okay, now I look at the next one. So I do it the same way. This is going up by 3, up by 3, up by 3, up by 3. And the x's are going up by 1, up by 1, up by 1. So my change in y over my change in x is 3 over 1, which is 3. So I know my rule starts out as y equals 3x, but I may have to do more. So I look, and I was like, nope, that's my rule. I don't have to do any more. So I'm done there. Let me look at the next one. So now I'm going up by 2, up by 2, up by 2, up by 2. And here I'm going up by 1, up by 1, up by 1, up by 1. So my change in y over my change in x is 2. So I know it starts out as y equals 2x, but there might be more. Now I look and I was like, well, if x is 0, 2 times 0 is 0, not negative 3. What do I have to do to 0 to turn it into a negative 3? Well, I have to subtract 3. So I'm thinking maybe that's my rule, and now I have to go test it. So if x is 1, 2 times 1 is 2 minus 3 is negative 1. That works. 2 times 2 is 4 minus 3 is 1. 2 times 3 is 6 minus 3 is 3. And 2 times 4 is 8 minus 3 is 5. So that worked. Okay. So now I'm going to look at the last one. And why don't you stop the video, try to do the last one on your own, and then look up and start it again. Okay, so now here I'm adding 1, adding 1, adding 1, adding 3, adding 3, adding 3. So my multiplier is always my change in y over my change in x, which is 1 over 3. So I know my rule is going to start out y equals 1/3 x. Well, 1/3 times 0 is 0. What do I have to do to get it to 2? Well, I have to add 2. So let's see if this rule works. What's 1/3 times 3? It's 1. Plus 2 is 3. 1/3 of 6 is 2. Plus 2 is 4. 1/3 of 9 is 3. Plus 2 is 5. And so my rule works. Okay, so the way we find the rule is we first find the change of y over the change in x. That becomes our multiplier. And then we plug in our multiplier and we figure out what we have to add or subtract for the rule to work. Okay, so this page is going to be homework, and the next page we'll have a different video for.